It's all right. Now we're good. Well, this looks sloppy up here now. How's anybody going to follow that? There you go. So again, you can almost think about this problem without having to do any work. You know it's negative. You know it's even degrees. So if it's negative even degrees, it's got to be going down and a down. We'll talk about that today a little bit. And both of these have to be bounces because they're multiplicity of 2. So if they're both bounces, somewhere I'm bouncing. Well, I know where, at -4. And then I'm also bouncing at 0. Whoops. So it's got to look something like that. So that graph is never greater than. That looks like a 7, right? Greater than is 7. I think the tricky was, like on this one, this would have been tricky. Let me erase all this stuff again because you can't see again. If they would have put the stupid equal sign right there, then it would not have been no solution. It would have been a solution of x equals 0 and x equals -4. That would have been the only time, because that's the time it's equal to 0. So you have to watch that stuff. That stuff's kind of tricky. You got to watch that. And that happened on a couple of those, I think, on the bounce, like this one. Because that was a bounce, and so that's where it's equal to 0, so it would just been 7. Great questions. A lot of your learning will come from the questions, not necessarily the homework. Okay, you had one.
How does the or equal to change the answer?
So if it's an interval, that's going to change it to a bracket. So if that one worked, if I went from 0 to 4, if it's an equal to, it's going to change it to a bracket because that's when it's equal to 0, right? If it's just less than, then it's going to be the parenthesis because at that number it's equal, which is not less than or greater than. Does that help you? I was just directing that to him, but does that help everybody else? I'm missing this whole row right here. I can't even see anything. My big old monitor. Get old, yeah, that's what happens. It's not as big as that monitor. I feel weird sitting down teaching, but it's kind of comfortable. What else, ladies and gentlemen? Yes?
Actually, number 20 on the
Worksheet C. 20, 14, 15, 16, 17, 18, 19, 20. Oh, This looks familiar. I may or may not have peeked at the test. I don't ever tell you what's on a test, but it looked. What's being recorded anyway? We know the open response questions on an AP pre-cal test. We know what they are. You will know what they are when you take the AP pre-cal test. You will know what the questions are. Everybody knows, so it's not just us. That's one thing different about this AP class than any other AP class. We know for a fact what the 3 questions are going to be. We know. We don't know what the numbers are. We don't know what the wording is, but we know about what it's going to entail. So we have that advantage of knowing that. Probably one of the few AP classes you'll ever take that you know going into it what the question is going to look like. And we're going to practice and practice and practice and practice and practice. Because it's going to be very, very similar to that. You just got to know how to transfer it over to something that might be a little curveballish. You kind of follow what I'm saying? So that looks familiar. Now, I don't know if it's per this, but something like that. All right, so here we go. My microphone's way over here, so I can deny I said any of that. This is H. This is K. I want to find all the intervals where H is bigger than K. So here I go. I'm going to go x4 minus 6x2. I want that to be bigger than 3x2. And this looks almost like what you looked like all those questions we just did. We got to get this thing, pardon my French, but we got to get it equal to 0. Not really equal to, but that's when I care. So I think what I'm going to do is move this over here. I don't like negatives if I can keep from it. So if I move this over here, oh, this is x to the 4th. Now I'm going to move this one back over here, sorry. Because x to the 4th is bigger. So what do I got now? It's subtracting it. Negative 9x squared. And now it's greater than 0.
Difference of squares.
Say again?
They're difference of squares.
It will be. But I'm going to factor first. So I'm going to take an x squared out of this. And now it's x squared minus 9. Ooh, difference of squares. Get used to seeing that. So we'll have x squared. We'll have an x plus a 3 and an x minus a 3 greater than 0. Did I go too fast for anybody? Anybody got a question about any of that stuff? And now it looks just like what we did, all these other problems. We got a number line. I got a 0. I got a positive 3 and a negative 3. I said that backwards, but those are my zeros. That's when it's equal to 0. I don't care about equal to 0. I care about just greater than. So plug and chug. Plug and chug. And they're all crosses. They're all crosses, so really you only need to plug and chug one thing. If it's plus over here, it's going to be a cross and a cross and a cross. Because there's no, I'm sorry. 0 is a multiplicity of 2. So they're not all crosses. It's a cross, cross, bounce. Anyway, we'll plug. Negative 4. Negative 4, that's always going to be a positive, no matter what, because it's always squared. Negative 4, that makes this negative. Negative 4 plus 3 is negative 1. Negative 4 and negative 3 is negative 7. That's negative. Positive and negative is a positive. Yay, that's what I want. That's a smiley face. Because we want it greater than 0. My guess is this is going to be a negative. Because it's a multiplicity of 1, it's going to be a cross. But we'll test it. Negative 2. This is a positive. Negative 2 makes this a positive. Negative 2 plus 3. Negative, negative, this is negative. Positive, positive, negative is always a negative. That's bad. This is a bounce. So I better get a negative. We'll make positive 2, though, just to make sure. This is always going to be positive. Positive 2 and positive 3 is a positive 5. Positive 2 and a negative 3 is a negative 1. That's still a negative. Funny how that works. And then 4, my guess is that's going to be a positive because it's a cross right there. So a 4. 4 makes this a positive. 4 makes this a positive, and a 4 makes this a positive, and a positive, and a positive, and a positive is a positive. So I want everything where it's greater than 0. So everything's greater than 0 from negative infinity to negative 3. And that one's a parenthesis because it's not equal to. And it's also from 3 to infinity. Whoo! It's a great question. Kind of like that one's a great question. And then, are those the only two we did that with? Yeah. Funny how that works. You'll see how asking questions will get you some knowledge. Knowledge you didn't know if you didn't ask that question. Okay. Ladies and gentlemen, I ask if there anything else over that lesson. Anything. Feel pretty confident about it. That's probably one of the harder lessons we've done. It's testing a lot of your prior knowledge. If you need more practice at factoring, let me know. You need to get good at factoring. You should be able to factor number 15 without even much hesitation at all. You should, I mean, it should get like, okay, I know I got to take an x out. And if I take an x out, I got x squared minus 8x plus 16. Now I got to go x, and that has to be a 4 and a 4, minus 4 minus 4. You got to get good at that. If you don't, you're going to have issues with time on the test. You're going to have issues with time on the test. If that takes you a while to do it, you're going to run out of time. Yeah. Oh, you got a hand up. What is it?
Could you please do on worksheet E, question 5?
The function is odd with a domain from -6 to 6. A portion of the graph is... Oh, so we're going off this graph. I'll make this a little bit smaller. So we're using this graph, and it tells me it's odd. This is interesting. So, and it only tells me it's defined from -6 to 6. So if this point is -6, 5... If that's -6, 5, and it's odd, then I better have a +6, -5. And so I just started moving points. If this is 1, 2, 3, that's -4, +1, -4, +1, +4, -1. Whoop, except that's a circle. That looks horrible. Can I erase with this? Oh, sweet. Circle. That's -2, +2, -2, negative. Oh, that's already done. So this gets connected like this. This gets connected like this. This gets connected like this. Oh, you know what? I lied to y'all. I lied. I said it always has to go through the origin, didn't I? This one doesn't. This is really kind of a... This one's colored in down here. Why is this one not? This one can't be colored in, right? Because
You can have 1x for multiple.
You can't have 2 y's for 1 x. That's kind of a trick. Okay. So g of 5. I just went g of 5. Boom. It looks like -3. If I go -5, it's definitely a +3. So if I go -5, +3, so I could say g of -5 equals 3. Therefore, g of 5 has to equal -3. That's kind of the work shown for it. Or you can go and circle it if it was a free response question. If that was a free response question, I better not see a -3 all by itself. That's a naked answer. So show something how you got it. Homeworks, I kind of expect that too. At least something. Fake it. Fake it. So g of -1, well, g of +1's right here. So g of -1 will have to be like right there. Did I get that wrong? What did I put on that one? So is it like 1.5, 1.4 something? Say again?
1.5.
Yeah. Like if you put 4, it's okay. If you put 3, it's okay. If you put 6, it's okay. I mean, we don't know exactly what it is. Does that help you on that one? Sir?
Wouldn't it be exactly 1.5 because the rate of change?
Yeah. Yep. You can figure out the slope through here, right? It's up 1/2. If it's up 1/2, then I go up 1/2 or down 1/2 over 1. That's being a little nitpicky, but it could be done exactly. that help you? I'm glad you brought that up because when I was doing that, I'm thinking I told the kids it goes through the origin and that one doesn't because it's a piecewise function. Yep. C is -2. So at -2, oh, this is a trick. So at -2, that's a whole. So that doesn't tell me what the value is at -2. So I need to go to +2. So at +2, that's the point. At +2, it's -1. At +2, this graph is -1. So at -2, it better be at +1. They use piecewise functions a lot in AP pre-cal too. And you guys are probably not as familiar with piecewise as I don't say you should be, you could be yet. So that's all this is. Anytime you have a whole lot of different things that are going on that you can't recognize what it is, it's a piecewise function because it's pieces of a different kind of function. This is like 1, 2, 3, 4, 5, 6, 7, 8 pieces. Like part of the piece is at -4, it's 3. That's a piece. Great questions. Great questions. I apologize mostly for getting the answers to you a little bit tardiness. I posted it yesterday when I left school, I think, but probably a little bit later than some of you guys wanted. Yes?
Could you please do number 6D on the same page?
Even, odd, or neither. P is this one. F is this one. And I'm adding them. So y equals x squared plus 3x plus x to the 5th plus 4x cubed. I'm just adding them. And I really should put this in order. So x to the 5th plus 4x cubed plus x squared plus 3x. I probably was tired on this one. I probably just told you neither without doing anything. But this is an odd degree. This is an odd degree. That's an even degree, and that's an odd degree. That's how I knew it was neither. In order to be odd, they all got to be odd at least. In order to be even, they all got to be even at least. But to check this, what I would do is I would plug in f of 1 and see what I got. And then plug in f of -1 and see what I got. If you get the same thing, it's even. If you get the opposite, I'm not sure I would plug in 1. Yeah, I'm okay. Yeah. If you get the same thing, it's even. If you get opposite, like a -4 and a +4, it's odd. And if you get something else, it's neither. There's a whole lot more neithers than there are evens and odds. And I knew that one was because right here, I'm going to get the same number, right? Because of 1 squared and 1. 1 squared and 1 squared is going to give me -1 squared and 1 squared is going to give me the same number. And then the next one, I'm going to get an opposite number. So it's not going to be the same, and they're not going to be opposites. Because this is going to give me a different number, and this is going to give me a different number, and that's going to give me the same number, and that's going to give me a different number. So they're all different except for one of them. So I kind of cheated on that one. I used my common sense mathematics major, which y'all probably don't have yet. You got the common sense, I think. You just don't have a mathematics major yet. Told you I don't have an education degree. I got a math degree. So I can't teach it. All I can do is do it. According to the law. What else? We good? We wasted enough time on this one? I thought this was a big lesson. I'm sorry. I shouldn't say lesson. Big assignment. Big assignment. Big assignment. Let's do 1-6. Let's do 1-6. Y'all see what it says? Topic 1-6, polynomial functions. So we're still in polynomials. Okay? And end behavior. And I know for a fact you guys were taught end behavior if you went to Bentonville High School and you were taught polynomial and you went to Algebra 2. I know for a fact the advanced, and I'm pretty sure the regular even did an end behavior. Polynomials, right? The end behavior is how is it behaving at the end of it, right? You got a polynomial. So a polynomial is some type of a function that starts somewhere, either negative infinity or positive infinity. It typically starts really low or really high. And at some point, we may or may not cross the x-axis, but we just follow our little pencils along. We do something. We can't come backwards because if we come backwards, it's no longer a function. So we're just basically starting somewhere, and we're just doing something, and then somewhere else we end up going up or we end up going down. That's what polynomials are. And so that's what we're carrying on this lesson today is we're carrying on the end behaviors, okay? And again, you know everything about this. We just got to fix some things that they want us to do. Okay, hold on. Let me get this. Let me hit this button. There we go. All right, let's change to gray. The end behavior of a function describes how a function behaves, acts, goes as it moves infinitely left or right. Okay? So is it going uphill? Is it going down? Pretty much. We don't like to say those words in this class. In other words, the end behavior is what happens to the values of, can I say y or can we say f of x or whichever one you want? In this class, we like to say f of x. I probably would say y. They're the same thing, right? As x increases or decreases without bound. So I can't do it. I've tried. Without bound. So that means infinity. Without bound is infinity. So x is decreasing without bound, we're going to infinity. X is increasing without bound, we're going to infinity. And hopefully you guys did it something to that effect. As x goes to infinity. My guess is that's what you guys did. I tried. As, no, I can't. As x, maybe I can, goes to infinity, f of x, I hope y'all did, f of x goes to, as x goes to negative infinity, f of x goes to, I'm hoping that, does that look familiar? That's kind of what y'all did, yes? Okay. If y'all did that, we're close to where we need to be today. We just got to do it one little detail different. But this always happened. This always happened. X always went to infinity and always went to negative infinity. You just had to tell me what y did. And y either went to infinity or went to negative infinity for polynomials. Okay? So notice this little box down here below it. End behavior and limit notation. So again, I'm going to tell you for a fact on the AP test, there will be a limit notation. You will have to write something in limit notation. And if you do not write it correctly, they are going to ding you. Miss Mims went to the grading last year. We have 3 or 4 teachers that go to the grading. What they mean by go to the grading is they go to places where all the tests come in and they grade. I go to grading. I just don't do it for pre-cal. I go for stats. And if you don't write it the way that they do, they're getting you dinged. And so you used to write this right here. X goes to negative infinity. I need to change that color. Y'all can't see that real well. That right there. That's what y'all used to write. Okay? Well, the way you need to write it now is we got to put the word LIM above it. LIM, that's limit. LIM above it, and then you're going to say X goes to, and then depends on if they want the left bound or the right bound. Depends on if they want the left bound or the right bound. If they want the left bound, it'd be negative infinity. If they want the right bound, it'd be positive infinity. And that's what they got down here, right? Here's the right bound is positive infinity, and the left is negative infinity. That's not like, you don't need big time rocket science for that. I wish they would have put the equal sign right here. So the limit as x is going to negative infinity of f of x. And they're basically telling you, so as it's going to the left, where's f of x going? Is it going up or infinity, or is it going down negative infinity? And that's the limit notation. This is verbally. Remember day one, I told you got to know how to do it graphically, algebraically, verbally. I don't remember what the fourth one was, but if you can do those three, you're good. This is verbally. As x decreases without bound. As x decreases without bound, then the values of f of x, whatever. We don't know until we know what the polynomial is. That's why it says ... We don't know what goes there until we know the polynomial. So this right here, guys, is limit notation. Get into the habit. Writing LIM and then putting x goes to, and then they depends on if they want the left or the right. If they want the left, negative infinity. If they want the right, positive infinity. So I'll say positive infinity, and then depends on what my function is. If my function is g, put g of x. If it's f, put f of x. If it's h, put h of x, and then you just put equals. And then you just tell me which way it's going. Okay, that's limit notation. If you don't put the x goes to infinity below it, you're getting dinged. If you don't put the g of x, you're getting dinged. If you don't put the equal sign, you're getting dinged. If you don't put the x and the arrow, you're getting dinged. There's only one way it can look. And so luckily, you know exactly what it's going to look like. All right, I'm done. Describe the end behavior. Verbally, left. Verbally, left. Left. As x decreases without bound. Was this f of x or was it y, or they didn't tell me. I can just say y. Y increases without bound. Can y'all see that? And then the limit statement, LIM, x goes to negative infinity. We'll call it f of x goes to positive infinity. Might be too low too. So I just did that right there. Oh, and now I got to do right. Verbally. As x increases without bound, y, you got to look, decreases because it's going down. Y decreases without bound. LIM, x goes to positive infinity. F of x is positive. Negative. There we go. I fixed it. Yes, no, maybe. You got to know verbally, and you need to know limit. So what type of polynomial is this? An even degree or odd degree? It's an even degree polynomial because they're both going the same way, right? All this stuff we should recognize. So it's an even degree polynomial. They're going the same way. It's both going up. It's actually the leading coefficient is a positive number because they're both going up. If the leading coefficient was a negative number, it would be going down. You know that negative x squared opens down. You know that positive x squared opens up. So here's verbally. X increases up, left, 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 left,
decreases without bound, y without bound. X increases without bound, y without bound. Like I'm getting 50% of my work just without even knowing the answer. Oh, this was a up. Increases without bound. Increases without bound. Limit. X goes to left, negative infinity. Limit. X goes to negative infinity. Right, and both of them were infinity. I can't do the little sideways 8 thing. I can write an 8 upside down, but I can't write them sideways. Y'all get it? Thanks. I'll say it again for you slower people. I can write an 8 upside down. It's the same. Okay. Sketch a polynomial. So there's 29 of you cats in here. I can have 29 answers. Negative infinity, negative infinity. Positive infinity, negative infinity. That means that I have an even degree polynomial. That means I'm going down here and I'm going down here, and then I can do anything else. Just don't cross back. Don't make it a non-function. Beautiful. Negative infinity is negative infinity. Positive infinity is positive infinity. We'll make that one easy. Y'all recognize all this stuff good? Same terminology. Y'all done all this before. For polynomials, it's easiest to find the end behavior. I don't like this. They're both freaking easy. For the polynomial, it's easiest to find the end behavior of the, I don't know. The right side goes blank. So I guess they want the right. This guy does it differently than I do it. This makes it harder to me. If the leading coefficient is even. Oh, I'm sorry. Yeah, is even. It goes positive if it's odd. No, I'm an idiot. Sorry. I hope y'all aren't doing this in pen. Positive. If the leading coefficient is even, it goes, yeah. And it goes, oh, see, I did this bad. Gosh dang it. Cuss. That's what I get for using his notes. I don't like his notes. I think this is what he's looking for. It goes up if the leading coefficient is positive. If the leading coefficient is negative, it goes down. If the leading coefficient is positive, it's going up on the right-hand side. If the leading coefficient is negative, it's going down. Doesn't matter if it's odd or even. Doesn't matter if it's odd or even. That's the way he does it. I don't do it that way. On the left side, it goes in the same direction if the degree is even, and it goes in the opposite direction if it's odd. I guess I'll see what he did right there. I don't do it that way. If it's even degree, they're going the same. X squared, X fourth, X sixth, X eighth. If it's even degree, they're going the same. So then I'm just looking to see are they going up or are they going down. And that's if the leading coefficient is positive or negative. That's telling me which way they're going. And if it's odd degree, and I just think of linear, you already know linear. So I don't care what else happens. I just care about the ends. Positive, it's going uphill. Negative, it's going downhill. This is mathematical dancing. Square root. Asymptotes. So, but he says, doesn't matter what it is. If the leading coefficient is positive, this right side is going positive. If the leading coefficient is negative, it's going down here. And then they look at the degree. I kind of look at the degree first. But again, that's me. That's what's kind of cool about all that. You can do it however you want to. Then he looks at the degree. If it's an even degree, then this is positive. If it's negative, it's negative. It's the same. If it's an odd degree, it's the opposite of this side. Whatever. That's why it's Burger King. Y'all know what Burger King is, right? Have it your way. You get to do it however you want. As long as you do it right, I don't care. Determine the end behavior. So these are different because it's odd. So the right has to be positive and the left has to be opposite because we're going uphill. This is an even degree and it's positive, so it's opening up. I don't care how you do this. This is negative, even degree. They didn't tell me how to. Oh, it says limit notation is not necessary. Whew. Glad I read the instructions first. Odd degree, negative, downhill. Careful. You're going to try to check on this one. Odd degree, downhill. Uh-oh. Dang it. You got to count. 1, 2, 3. Odd degree. Woo. Positive, positive, negative. Downhill. Can y'all see it? Yep. So positive infinity, negative infinity. Write the limit statements for the end behavior. Here, I'm going to get 50 points right here. Lim x goes to infinity. Fx equals. I could teach a fourth grader how to do this part. Lim x goes to negative infinity. Fx equals. There, I got most of it right there without even doing it right. Lim x goes to negative infinity. G of x. Lim x goes to infinity. G of x. Whoop, this one's negative. See, it's easier to add than negative. Equals. I didn't even answer the question yet, but I got most of it. Let's go back to black. Even, negative, down, down. Down, down. Odd, positive. That's odd, positive. So left is negative, right is positive. If you don't like the looks of your limit notation, practice it. I don't say it has to be neat. Mine's not really neat, but I can follow it. It's got to have the LIM. It's got to have X goes to, and that has to be underneath it. And then G of X is out to the side. G of X is kind of the size of all that together, if you ever see it typed. Well, you saw his typed, I guess. This is like a subscript type deal. It's kind of small. Oh, what we got now? Is that it? Just 3 more left? Use a graphing calculator to determine end behavior. I don't need it for this first one. I know what it looks like. It didn't tell me how to write it. Probably limit notation. X goes to infinity. Limit. X goes to negative infinity. This is f of x equals. This is f of x equals. This is limit. X goes to infinity. G of x equals. Limit. F of x goes to negative infinity. G of x. This is limit. X goes to infinity. H of x. Limit. X goes to negative infinity. Hx. And this one I know. Infinity, infinity. So that's just a quadratic it opens up. And these, I don't know. I think they're both zeros. Nope. They're both 2s. Bless. 2 times. Don't start that again. Hold your breath 10 minutes. Y'all caught that too, didn't you? So punch it up and see what it does. These are not infinities. Okay? These are not infinities. They're going to some number. And if you have to, look at the table, whatever, right? I don't want to spend time in class to do that, but they're getting you ready for future stuff. They're getting you ready for future stuff. So, again, just so you know, we're going to y equals, punch it up, look what it looks like, graph it if you have to. My window's jacked up. Your windows will start getting jacked up. Always hit zoom 6, zoom 6, zoom 6. Zoom 6 will do the 6, 6, or 10, 10, 10, 10, 10. Okay? Beautiful, right? That one's just something else. So get somewhat comfortable. If you don't like that, hit second, y equals, and you can look at the table maybe as we're going to infinity, right? Just start making those bigger numbers, smaller numbers. I'm not as concerned, obviously, with those last 3 questions. But I think they're just wanting you to look at, see, when they're not polynomials, those won't be infinities. It's not that big of a deal. We're dealing with polynomials, so all we're going to be dealing with is infinities. Okay, 27, you got 20 minutes. A little under. That took a little bit. That didn't take longer. It was just. Okay, so you got your little Chromie books. I hope. If you don't, then we'll take it some other time because I don't have it on Facebook. It's on Delta Math. Go to, what's that thing called? Clever. Go to Clever, go to Delta Math, and you should see it there. Not yet, but in just a second. I'll have to turn it on. Well, let me hit